of ee102 online mentoring. So I'm Rajanath and I will also be taking this week's mentoring with you. So we'll start off this week's mentoring. So there is three important application topics that has been prepared for this session, which is linearity. We'll look at some examples of it. Then there is superposition, and then lastly there is also super transformation, but super transformation we will look at together with the Thevenin's theorems that we will be discussing next week. Okay, so this is a week behind of mentoring lesson because we spend more time on nodal and mesh analysis because that was really important. So now this is what we will start off from, is linearity. So as we will go through this two applications that we are going to discuss today, we will actually see the importance of mesh and nodal analysis and how they are applied into these applications, okay, to calculate whatever is required by the question, whatever the question asks you. So first thing is linearity. So what is linearity? Okay, so linearity is a circuit means that as current is changed, the voltage changes proportionally. Okay, so a linear circuit is one whose output is linearly or directly proportional to its input. So linearity deals with, you could say it deals with ratio. Okay, so let's say current will be given and they will tell us, a question will ask us to find I0. We will assume a value of I0, work backwards to see what is our supply, and then we will use the ratio of supply is equal to I0, and then we'll be able to find it. Okay. So the general formula that is usually used is same, V is equal to IR, and then the application is also there for whatever way you want to know. Okay. So as you can see, that is an example. Okay, so it says find I0 when our voltage source is 12 volts and our voltage source is 24 volts. Okay. So what this example actually is asking us is, okay, so if you see our Vs here, okay, so Vs, okay, so if our Vs is 12 volt, what is our expected value of I0? Okay, what will this I0 be? Okay, that is what the question is asking us. And note, we also have a dependent source, and this source is dependent on the value of voltage that we will have across the 2 ohm resistor. Okay, so if you see now, if you try and see the circuit, first thing you have to do is to find a general equation. Okay, a general equation will help us actually realize or actually find a variable, or in this case Vs, that whatever value we will substitute, we will be able to get our equation. Okay, so which method we can use to do this is mesh analysis. Because looking at this circuit, it is asked. Now this question is only asking me to find I0. Okay, it is not telling me to use mesh or node, so you can use either. So looking at the circuit, mesh analysis will be the best option. So then you label your I1 and I2 for the two meshes, and you start. Okay, so you start off by 6I1 plus 2I1 plus 4 into I1 minus I2 plus whatever your Vs is, okay, is equal to 0. Okay, and then you rearrange the terms, and you should be able to get that as you should be able to get that as 12I1 minus 4I2 plus Vs is equal to 0. Okay, and then looking at mesh 2, since you're going upwards again, okay, So we will do minus Vs plus 4i2 plus 8i2 plus 4i2 minus 3Vx. Okay, and Vx is 2i1. So then you put the value of 2i1 instead of Vx, and you should be able to get minus 10i1. Okay, so label this as well just to show what is happening there and that portion. Okay, you should be able to get minus 10i1 plus 16i2 minus Vx is equal to 0. Now if we solve for equation 1 and equation 2, we get 2i1 plus 12i2 is equal to 0, and then i1 is minus 6i2. Okay, and then minus 6i2 minus 76i2 is equal to Vs. Note, looking at this mesh, whatever value for i2 is will be the value for i0. So we find the general equation for i2 as Vs upon 76, and then we just substitute the value of 2 Vs that is given, 12 upon 76, and for i2, for the other current of i0, when our supply is 24 volts, we'll get 24 upon 76. So it's better to leave it as a fraction so we can get a clear answer, and this is what you get. Okay. This was just to help us understand the basics of linearity. Okay. The next question is, assume I0 is 1 amp and use the linearity to find the actual value of I0 in the circuit. Okay, so this is a good application question for us. Okay, so as you can see, now this is a general circuit that has been given. We have to find this value of I0. Okay, what this value actually is. Okay. In order to find that, what we will do is, first we will label our current directions. Okay, because it will be easier for us to use Kirchhoff's current law, so we'll be able to add these currents. So 15 amps, then this is I0, then this is I1, then I2, then I3, then I4. Okay. Now to start off, what we have to assume is I0 is equal to 1 and work backwards to find what our value for I4 is or Is is. Once we will be able to find that, then we can use ratio or linearity property to get the actual value of I0. Okay. So if I0 is 1, okay, we will be able to get the voltage across this node. Okay, V2. We will be able to find out how, because V is equal to IR. Whatever the voltage is across this part, the branch will be same across this branch. So to find the voltage here, we have assumed that the current is 1. So V is equal to IR. We get our voltage as 8 volts. Okay. Now we have the voltage here, we have the resistor here. Will we be able to find the current here? Yes. So I1 will be 8 volts divided by 4, which is 2 amps. So to find the current here, so sum of current entering the junction is equal to sum of current leaving the junction. So our I2 value will be I1 plus I0, which is 2 plus 1, so 3. So 3 amps going across this. Our I2 is 3 amps. Now to find the voltage across this, what we can do is add these two in series, then these two in parallel, and then this, whatever value you have here, okay, whatever value will be here, you add it with this in series, and then since you know your current now of I2 as 3, so 3 times whatever your value of resistor you get here, will get you the voltage across V1 and V2. Once you have this, then you'll be able to know what is the current that is going through here. How? You have a voltage, you have resistance, you will be able to get the current. Because in parallel current divides, but voltage stays the same. Once you have these two, you add that. So this is 3 amps, and you divide this, you get this as 2 amps. So 2 plus 3 is 5. That means our assumed value, if I0 is 1 amp, we get our IS as 5. Okay. Now, but the question is 15 amps. So we can use the linearity property. Okay. Linearity property says if I0 is 1, our IS is 5 amps. What will be our I0 when IS is 15? So you cross multiply, 15 divided by 5 is 3 amps. So our value for I0 is 3 amps. Okay. So this is application question. Note we have used, for most parts we have tried to use nodal analysis. Okay, so this circuit it's really good if you use nodal analysis. Please make sure when the question is asking you to use linearity property, you are using linearity, okay? And this is linearity. So if you use some other things, then you might end up getting no marks. Okay. Next one is superposition. If you're looking at superposition, superposition is basically taking the voltage or current across the resistors. Okay, so what you're doing is usually in superposition you have 2 or 3 different sources: current source, independent and dependent, voltage source, independent and dependent as well. Once you have done this, once you have this, so what you do is, if there is a current source, you open it. Okay, and then let's say you have a current source and a voltage source. So you open circuit for the current source, and then you solve the circuit using that voltage supply. After that, then you short circuit the voltage branch, and then you remove the voltage and you work with the current supply, and whatever answer you get, you add those two, that will give you a total answer. Okay. So okay, so note that you know how in supernode and supermesh it was dependent and independent, that we actually tried to cancel or like work with. But the only thing for superposition is, if the supply is dependent, then you don't take it out. Okay, you leave it intact. You only turn off the independent source except one source, right? And then you find either the voltage, the current, using either mesh or nodal. That is up to you, because that is the application part of nodal and mesh. Okay. So that is for superposition. Looking at the question, a simple question is given with two sources. One is a voltage source and one is a current source. So if you look at it, first, okay, let's say we want to turn off the 3 amp source. So what we do is we open this circuit. Okay, so this becomes this. Okay, so this part is open. Okay, so this part is open. Yeah. And then you solve using mesh. Okay, because mesh is easier. Then you go around, because the question is asking us to find the voltage across the 4 ohm resistor. So you go -6 plus 8I1 plus 4I1. I1, and then you find the value for I1, whatever value you have for I1, let's say in our case is 0.5. 0.5 times 4 ohms will give you 2 volts. Okay, so that is from only one source. Now we have to consider another source, the 3 ohm. So then this part is here, okay, short circuited, meaning the voltage supply is removed or short circuit or turned off. And then what method to use here? Mesh will be a bit difficult and long, so nodal analysis will work better in this case. So you solve for the current because voltage is equals to current times resistance. So V is equal to IR. So our current we found as 2 ohms. 2 ohms multiplied by 4 is 8 volts. So from our 6 volt resistor, our 6 volt supply, the voltage across the 4 ohm resistor is 2 volts, and from our 3 amp supply, our voltage across the 4 ohm resistor comes to 8 volts. So now the total voltage across the 4 ohm resistor will be 2 volts plus 8 volts, which is 10 volts. Okay, so this is what you get. And another question, this is a good application question because it has some independent source here as well. Okay, so there is an independent source. Note that while solving the question, we will leave this intact, because this is a dependent source. Okay, so first thing you do is you remove the turn of the 20 volt. Okay, so this part is here. It's short circuit, and you solve using mesh. Okay, so I want you to go through the details of how to get the loops because this is what we did for the past 2 weeks. Okay, in our e102 session. And you should be, because since the question is asking you to find I0, and I0 is going through the across the 5 ohm resistor. So you get I0 as 52 upon 17 amps. Okay. Once you have done this, okay, then you turn off the 4 amp. You turn it off by opening the circuit. And what is the best way to solve it? Yes, mesh will be best. So you solve it, you get your equations, 2 equations, okay, and you get your value of I0 as minus 60 upon 17. Okay. Now you have found your value for I0 from the 20 volt supply. We have also found using the 4 amp supply. What you have to do now is add. So once you add these two, you should be able to get your true value of I0, which is the total of the 2 supplies, which is minus 8 upon 17 amps. Okay. So just a quick review of whatever we have covered so far. Note that linearity is an application of nodal and mesh analysis. It uses ratio. Okay, it uses ratio to find whatever the question is asking, either voltage or current, I0, P0. Just remember to really know what to use where, especially the ratios and your basic understanding of parallel and series. Okay, we have looked at some examples using linearity properties to find out values. Okay, we have looked at also another example on linearity to actually know if we have mastered it. Then we went to superposition. Note that dependent sources are left with the circuit, and the independent, we turn off all independent sources except for one, and we use our mesh or nodal to solve it. Okay. Same thing is done. So for independent voltage sources, you short circuit, and for the independent current sources, you open circuit. Okay. We have looked at the example on what happens, or in case you forgot, how does the open circuit looks like. You can look at the example of a 3 amp supply and a short circuit, how it looks like. We have looked at it in the 6 volt supply. Okay. So this is all that we have for mentioning today. Hope that you have learned something. Please don't hesitate to write down questions on the discussion forum on your Moodle shell for ee102. then we can discuss whatever confusions you have. Okay. Thank you very much for your time, and hope that you have learned. So all the best with your revision. Thank you.